Hello friends, this video on electrochemistry part 16 is brought to you by examfear.com. No more fear from exam. Let's take this numerical now. We have to calculate the standard cell potential of the galvanic cell in which this reaction occurs. So chromium is in solid state. It is oxidized to Cr3 plus and Cd plus to cadmium ion is reduced to cadmium. So first we have to find the standard cell potential, that is we have to find E naught, and then we have to calculate delta G, and we have to find equilibrium constant. These three things we have to find. So let's see in this how many electrons are involved. So 2 chromium becomes 2 chromium plus 3 ion, that is 6 electrons are involved here. Correct? So if you want to see, if you want to write the cell representation for this, chromium gets oxidized to Cr3 plus, and on this cadmium 2 plus gets reduced to cadmium. Want to find the E of the cell, or E naught is nothing but E right minus E left. E right is this, that is nothing but E of cadmium 2 plus to cadmium, reduction of cadmium, minus reduction potential of chromium 3, that is Cr3 plus to Cr. Please note it is Cr3 plus to Cr, not Cr to Cr3 plus, right? So using table we can see the value, that is nothing but 0.4 minus 0.74. Correct? And there is something plus 0.34 volt. So that is my E naught of the cell. First part done. Second is delta GR. So delta GR is nothing but minus NF E naught. You know this. It is minus, N is what? 6. F is 96487 coulomb per mole. And this is 3.34 volt. That is nothing but joule per coulomb. Cancel. So you solve this, you get minus 196,833.48 joule per mole, and you can make it in kilojoule per mole, 196.833 kilojoule per mole. That is my delta G. I have to find K. So that we can do, delta G is nothing but minus RT log K. This is something we have seen. Sorry, ln K. This is ln K. Correct? And there is nothing but minus 2.303 RT log K. So we know all the values, we can find the value of K. Right? Or you can see that log K is nothing but minus delta G by plus 2.303 RT. Put all the values, delta G in joules per mole. Please note we can't put in kilojoule per mole, we have to put in joule per mole only. This is minus of minus 196,833.487 joule per mole by 2.303 RT 8.314, T is to 98. You solve this, you get 34.496, and that is the value of log K. So K will be what? Anti-log of this? Anti-log of 34.496. And that is nothing but 3.13 into 10 to the power 34. And that is my answer. Correct? Similar to this same reaction, you have a way to find, similar question, we have to find standard like cell potential, that is we have to find E naught of this reaction, we have to find delta G, and we have to find K. Same thing we'll do. We'll see this in this reaction. Plus 2 goes to plus 3, that means only one electron is transferred, and here plus Ag plus becomes Ag, one electron gets transferred, right? So first let's write the cell representation. So this is Fe2 plus is oxidized to Fe3 plus, and then Ag plus is reduced to Ag. correct? So E naught cell you have to find is nothing but E right minus E left. What is right here? This guy. E of Ag plus becomes Ag minus E of left, that is E reduction of left, that is Fe3 plus becomes Fe2 plus. Please note it is Fe3 to Fe2. I'm talking about the reduction of this. So you can check the value in the chart. This becomes 0.8 minus 0.77, that is 0.03 volt. Correct? First part is done. Delta G minus NF E naught. N minus into N is what? 1 electron. F is 96487 coulomb per mole, and C is 0.303 volt, that is 0.03, that is joule per coulomb. This gets cancelled. So we saw this minus 2894.61 joule per mole. That is the answer. If you want, you can say minus 2.8 kilojoule per mole. Delta G is done. Same thing, K you can find delta G naught is equal to minus 2.303 RT log K. You put all the value in this equation, I won't solve for you. You get K as 3.2, and that is my answer. Because in this I know delta G naught, this is this guy 2894.61 joule per mole. It has to be in joule per mole, not in kilojoule per mole, right? And then R we know 8.314, T is 298. Put the values, get the answer. The button cell widely used in watch and other device, the following reaction take place. Actually, we'll study this button cells in the next few slides. We'll see the working of this. So here the reaction take place is zinc is oxidized to zinc ions, and Ag then becomes Ag plus 1 is reduced to Ag, right? That's what happens. Now we have to find the delta Gr and E. So E cell will be what? Er minus El, correct? If you want to write this equation, it can be zinc is oxidized to Zn2 plus and Ag plus is reduced to Ag, correct? That's what is happening. So E right minus E left, and that is nothing but E of reduction of Ag plus to Ag minus reduction of zinc ion to zinc. This is 0.8 and this is minus 0.76. So this is 1.56. So this is 1.56 volt. E is done. Delta G is nothing but minus NFE naught. And N is what? How many electrons? If you see, there are 2 electrons. Zinc 2 Zn plus 2 electrons. 2 Ag plus becomes Ag, 2 electrons. There is 2 electron transfer. Minus 2. N we know. Sorry, N is 2. F we know. 96487. Yeah. Coulomb per mole into 1.56 volt, that is nothing but joule per coulomb. Cancel. You solve this, you get minus 3.01080 joule per mole. That is nothing but minus 3.01 into 10 to the power 5 joule per mole, and that is my answer. Thank you. Visit examfear.com to watch more videos, attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.